This is the 2.4 to 2.7 study guide. When a variable is replaced by a number and the resulting equation is true, then the number is called a blank of the equation. Solution. Talked about this in class today, if you were in class today. And I think fourth period. We always talk about solving for x. Why do we solve for x? So that the number that we plug in makes the statement true. The solution makes the statement true. The integers 17, 18, 19 are examples of consecutive integers. Consecutive integers, like in a row. Alright. X is the set of numbers such that x is greater than 2. Okay, and they want you to graph it and write it in interval notation. Oh my god, I have a cramp in my foot. Okay, so graph it and write it in interval notation. So, ouch, I've got 1, 2, 3. So it is greater than or equal to, so it is a bracket. Because my variable is first, I can go ahead and shade the direction that my arrow is pointing. Alright, and I'm going to go ahead and write it in interval notation. Bracket at 2 goes on forever in the right direction, so it is 2 to positive infinity. Okay, here we have x is a set of numbers such that 3 is less than or equal to x, which is less than 7. Remember, don't overthink it. X is between 3 and 7. So draw your number line. 3, 4, 5, 6, 7. At 3, make a bracket because it's less than or equal to. At 7, make a parenthesis and shade in between them. X is in between them, so shade in between them. Don't overthink it. The only reason I want you to look at these is to know whether you make a bracket or a parenthesis. Other than that, x is in between 3 and 7, shade in between 3 and 7, bracket at 3, ends at 7, parenthesis. It's from 3 to 7. Look how much they have in common. 3, 3, 3. 7, 7, 7. Bracket, bracket. Parenthesis, parenthesis. Okay, x, this is x, and x is between here. Okay, it's that easy. Next, we've got, do a little bit of solving here. Move our smaller z to our larger z. So we're going to subtract 2z from both sides, leaving me z, because 3z minus 2z is just z, plus 7 is greater than 3. Subtract 7 from both sides, leaving me z is greater than negative 4. Then you have, remember you're doing negatives here, so it's negative 4, negative 5, negative 6. I really should have done, let me erase that. I really should have done negative 4 in the middle. So let's do negative 4 here, so it'll be negative 3, negative 5. That's better. Now, my variable's first, so I'm going to go ahead and shade the direction the arrow is pointing. Remember, this looks like an arrow if I put a line right there. So it is going to be a parenthesis because it is just a greater than symbol. And I'm going to shade this way because that's the way the arrow is pointing. So it's a parenthesis, negative 4, and it goes on forever to positive infinity. And positive infinity is always a parenthesis. So it's from negative 4 to positive infinity. Alright, here the first thing I need to do is distribute my 4. So I have 4x plus 1 is less than 4x plus 16. Subtract 4x from both sides. Cancels on both sides, leaving me 1 is less than 16. Is this a true statement? It is a true statement. So if you get a true statement, remember, your answer is all real numbers. But they asked you to write your answer in interval notation. So interval notation is just negative infinity to positive infinity. Alright, here we have negative x is less than negative 2, but I don't want to know what negative x is. I want to know what positive x is, so I need to divide by negative 1. Anytime you divide an inequality by a negative number, you have to flip the sign. So notice it was a less than, now it's a greater than. And negative 2 divided by negative 1 is positive 2. So I end up with x is greater than positive 2. So put your 2 in the middle. Got 1 here and 3 there. Your variables first, so shade the way the arrow points. So the arrow points this way. So it's going to be a parenthesis because it's just greater than. It's not or equal to. So I'm going to shade this way. So you have 2 with a parenthesis to positive infinity. And that's what you got for number 7. Ooh, fun. Fractions. So the first thing I'm going to do is I'm going to look at my denominators. I've got 8, 2, and 16. So remember, I got to figure out the LCD. So I write LCD up here with my little arrow. I pick my largest denominator, which in this case is 16. And I say, does 8 go into 16 evenly? It does. Does 2 go into 16 evenly? It does. Does 16 go into 16 evenly? It does. So my LCD is actually 16, so that works out nicely. So 16 multiplied here, 16 multiplied here, and 16 multiplied here. So 16 divided by 8 is 2, 16 divided by 2 is 8, and 16 divided by 16 is just 1. Now multiply what you've got left. You've got 2 times 7 is 14, plus 8 times 1 is 8, is less than or equal to 1 times x is just x. 14 plus 8 is 22, so 22 is less than or equal to x. Now you have two options here. Because the variable is not first here, you can flip it, or you can just remember, because the variable is not first, you shade the direction the arrow is not pointing. I'm a flipper, so I like to flip it. So remember, the mouth of the inequality is open towards x, so just make sure the mouth stays open towards x. So I go x, mouth open towards x, 22. Okay, so make sure you flip it correctly. So then I go to graph it, put 22 in the middle. Okay, now that my variable's first, I can shade the way the arrow points, which is this way. Shade this way. So you've got bracket 22 to infinity, and that's your answer. Okay, on to number 10. Alright, first thing we're going to do is, we can do one of two things. We can either distribute the 15 or we can divide both sides by 15. Let's actually divide both sides by 15 since the other side has a 15, and it's going to make everything really easy. So 15's cancel here, and be careful guys, don't just go, oh, 15's cancel. 15 over 15 is 1. So over here it's 14x plus 1, and it would be times 1. But we don't need to do that. That's silly. Okay? So it's greater than, but over here, you do need to write the 1. Because otherwise you would have nothing on the right side. Over here, we don't need to write times 1, because that would still just be 14x plus 1. But over here, you do need to write the 1, or you would have nothing over here. So now let's solve. Subtract 1 from both sides, giving you 14x is greater than 1 minus 1 is just 0. 0 is a number. Divide both sides by 14. X is greater than 0 divided by 14 is just 0. So when I go to graph, treat 0 like any other number, guys. 0 goes in the middle, 1 here, and negative 1 here. It's just a parenthesis. variable first, so shade the way the arrow is pointing. So I have 0 with a parenthesis to positive infinity. Okay, a student scored 71, 83, and 96 on 3 algebra tests. What must he score on the 4th test in order to have an average of at least 85? So we need to write our inequality here. So we have 71 plus 83 plus 96 plus x is greater than or equal to 85, because remember he wants at least an 85, and we're doing an average, so you need to divide by 4. Now you could have, if you wanted to, added up 71, 83, and 96 first and then added it to x. But this will show you the original problem. So let's do 71 plus 83 plus 96 is 250. So you have 250 plus x over 4 is greater than or equal to 85. Okay? So I'm going to multiply 4 by both sides to get rid of my fraction. So you've got 250 plus x is greater than or equal to 340. Then you're going to subtract 250 from both sides, and you get x is greater than or equal to 90. So what that means is they have to get a 90 or better on the test in order to have an 85 in the class. So your answer would just be 90 on that one. Alright, number 11. The absolute value of x minus 1 is equal to 5. So remember, when you have an absolute value is equal to something, the way that you're going to get rid of these absolute value bars, and you can't do anything with anything inside of the absolute value until you do this, is to break the equation into 2 problems. X minus 1 is equal to 5, and x minus 1 is equal to negative 5. So here you're going to add 1 to both sides, giving me x is equal to 6. And then here you're going to add 1 to both sides, giving me x is equal to negative 4. So your solution set is negative 4 and 6. Alright, now if you have absolute values on both sides, same exact concept. The only difference is we have expressions instead of just numbers. So on the left, you just drop the absolute value bars. You have 9x minus 9 is equal to x plus 7. But on the right, you have 9x minus 9 is equal to negative the quantity x plus 7. So you need to be careful. You need to put x plus 7 into parentheses and put negative out front, because you're going to then distribute the negative. So over here, we're going to move our smaller x to our larger x. So you're going to subtract x from both sides, which gives you 8x minus 9 is equal to 7. You're going to add 9 to both sides, which gives you 8x is equal to 16. Divide both sides by 8. You get x is equal to 2. Over here, distribute your negative. So you have 9x minus 9 is equal to negative x minus 7. Add x to both sides. You get 10x minus 9 is equal to negative 7. Careful not to forget your negative. Add 9 to both sides. You get 10x is equal to 2. Divide both sides by 2, and you get x is equal to 1/5, because when you reduce 2/10, you get 1/5, because they can both be divided by 2. So here your solution set is 1/5 and 2. Alright, here what I like to do on this side, I know the absolute value of negative 3 is just 3. So instead of writing absolute value of negative 3, I just write 3, because that makes my problem a lot easier to solve. Alright, so here when I split this up, I do 5x minus 1 over 6 is equal to 3, and 5x minus 1 over 6 is equal to negative 3. So by switching that absolute value of negative 3 to just a 3, it makes this look a lot more like a regular problem. Alright, I'm going to multiply both sides by 6 to get rid of this fraction, giving me 5x minus 1 is equal to 18. Add 1 to both sides, giving me 5x is equal to 19. Divide both sides by 5, you get x is equal to 19 over 5. Same thing over here. Multiply both sides by 6. You get 5x minus 1 is equal to negative 18. Add 1 to both sides. You get 5x is equal to negative 17. Divide both sides by 5. You get x is equal to negative 17 over 5. So here your solution set is negative 17 fifths and 19 fifths. Alright. Okay, so you have the absolute value is less than 2. So the first thing you need to figure out is my absolute value isolated? It is. It's completely by itself over here. So then you need to ask yourself, is it a less than or is it a greater than? The but is towards the absolute value, since the absolute value is in the front. So it is a less than. So I need to use the formula for less than, which is negative a is less than x, which is less than a, where everything inside of my absolute value is x. Everything inside on the other side of the inequality is a. So in this case, negative a, in this problem a is 2, is less than x. In this problem x is x, so that's easy, is less than a, and in this problem a is 2. So when I go to graph this, again, don't make this more difficult than it is. X is between negative 2 and 2. So when I go to graph, shade between negative 2 and 2. When you go to write your interval notation, it's from negative 2 to 2. Don't make it more complicated than it is. Look how simple it is. Negative 2, negative 2, negative 2. 2, 2, 2. Parenthesis, 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 parenthesis. Okay? You guys got this. Okay, so here we have the absolute value of x plus 15 is greater than 17. First things first, make sure that the absolute value is isolated. It is, so we can go ahead and check to see if it's greater than or less than. This is a greater than problem. The mouth of the inequality is open towards the absolute value, which tells you the absolute value is greater than 17. So we're going to use the formula. X is greater than a, or x is less than negative a, where everything inside the inequality is x. Everything inside the absolute value is x, and everything on the other side of the inequality is a. So, x, which in this problem is x plus 15, is greater than a, which in this problem is 17, or x, which in this problem is x plus 15, is less than negative a, which in this problem is 17. Subtract 15 from both sides. You get x is greater than 2, or subtract 15 from both sides. You get x is less than negative 32. Okay, so I'm going to graph this. So I've got negative 30, negative 25, negative 20, negative 15, negative 10, negative 5, 0, and 5. Whew. All right, so let's color code. Red, blue. So red, x is greater than 2. So 2 is right here. It's a parenthesis because it's just greater than. Shade the way the arrow points because the variable's first. X is less than negative 32. Negative 32 is all the way over here. Shade this way. You guys get the idea, but I'm running out of room here. So if my arrow goes all the way to the left, it is negative infinity. It goes to negative 32. It is a parenthesis. What sits in between? You sit in between the ors. Where does the graph start again? The graph starts at 2 and goes to positive infinity. And that is your answer. Okay? All right. First question. Is my absolute value isolated? In this case, no, it's not. So the first thing I need to do is subtract 5 from both sides, giving me the absolute value of x is less than or equal to 5. Now it is isolated. So then I'm asking myself, it's a less than, or is it a less than or a greater than problem? It's a less than problem because the but is towards the absolute value. Touch the but. So you have negative a is less than or equal to, because this one's an or equal to, x, which is less than or equal to a. Everything inside the absolute value is x. Everything on the other side of the inequality is a. So in this case, negative a, which is 5 in this problem, is less than or equal to x, which is just x in this problem, which is less than or equal to 5. Don't overthink it. Okay? Don't overthink it. 0, 5, negative 5. Bracket on negative 5. Bracket on 5. I'm not sure why I'm yelling. And then you're going to shade in between. X is in between negative 5 and 5. Shade in between negative 5 and 5. Bracket on the graph. Bracket in your interval notation. Bracket on the graph. Bracket in your interval notation. Okay? It's as easy as that, guys. All right, 17. Is my absolute value isolated? It sure is. Is it a greater than problem or a less than problem? It's a greater than because the mouth is open. But guys, red flag, big red flag, we have a negative here. So let's think about what it's saying. In this case, it's greater than a negative. What kind of number is greater than a negative? All positive numbers are greater than a negative. So what do we know about our absolute values? An absolute value will always give you a positive number. So any number we put in here is going to give us a positive number. So any number that we put in here is going to make this a true statement. So no matter what, we're going to have a true statement, which means our answer is all real numbers or infinitely many solutions. However, we want it in interval notation, right? So we have to put negative infinity to positive infinity. And if they wanted you to graph that, guys, you would just draw your regular number line and you would just shade the whole thing. It would go on forever and ever and ever. Okay? That's what it looks like. Forever and ever. All right. Okay, first ask yourself, is my absolute value isolated? It sure is. Is this a greater than or less than problem? This is a less than problem. But again, negative, big red flag. Let's talk about it again. We have a less than problem. Absolute value, less than a negative number. What kind of numbers are less than negative numbers? Only negative numbers. Is that possible? Is that possible? Can you have an absolute value less than a negative number? What do absolute values represent? Distance. Can you have a negative distance? You cannot. So it's a big fat no solution, guys. All right, here we go. So we got to solve this first. So we're going to subtract 2 from all 3 pieces, giving me negative 21 is less than or equal to negative 3z, which is less than or equal to negative 12. Then we're going to divide all 3 pieces by negative 3. what happens when we divide an inequality by a negative? We flip our signs. So this becomes positive 7 is greater than or equal to, it was less than, now it's greater than. Z, which is greater than or equal to, was less than, now it's greater than. 4. A negative 21 divided by a negative 3 is a positive 7. A negative 12 divided by a negative 3 is a positive 4. Now, I'm going to flip this around to make it make sense, because the 7 here and the 4 here, that doesn't make sense to me. Okay, so I'm going to flip it around because I'm a flipper. Okay, so just make sure you flip everything. The 4, notice the butt is towards the 4. And then the Z, and then the 7 goes here, and notice the mouth was open towards the 7. I flipped everything. So you got to be very careful there. Okay, so then you go 4, 5, 6, 7, 8. Z is in between 4 and 7. So shade in between 4 and 7. It's as easy as that. Okay? And number 20, I'm going to subtract 9x from both sides, because I need to keep something over here, giving me negative 6 is less than negative 6x. I divide both sides by negative 6. When I do so, I need to flip this sign because I'm dividing by a negative. Negative 6 divided by negative 6 is 1. I flip the sign, it was less than, now it's greater than. 1 is greater than x. Or, over here I have negative 2x is less than or equal to negative 6. Divide both sides by negative 2. When you divide by a negative, you flip the sign. So it was less than or equal to, now it's greater than or equal to. Negative 6 divided by negative 2 is positive 3. So I have x is greater than or equal to 3. Now I'm going to flip this to put my variable first. The butt is towards the x, so keep the butt towards the x. So it's x is less than 1. So I'm going to go ahead and color code these for you. Oops, that's not what I meant to do. But that's fine. So I've got 1, 2, 3. So in red, x is less than 1. So it's a parenthesis because it's just less than. In blue, x is greater than or equal to 3. So it's a bracket. So now I need to go ahead and write this in interval notation. Going on forever to the left is negative infinity to positive 1, which is a parenthesis on the graph. Union. U sitting in between the ors. It's a bracket on the graph. At the 3, going on forever to the right, is positive infinity. And that is it. That is the study guide. You guys have a great night, and I will see you tomorrow.